Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have n equals to 1 plus square root 5 over 2, and we solve this problem for the values of n to the power of 12. So this ratio is known as the golden ratio. So we solve here the golden ratio problem. So that now first we simplify this given equation, and we move this 2 in the left hand side, and we have 2 times of n equals to 1 plus square root of 5. So after that we move this plus 1 to the left hand side, and we get here 2n minus 1 equals to square root of 5. And in the next step we take the square on both of the sides of this equation, and it will be looks like in this form: 2n minus 1 whole square equals to square root of 5 and its whole square. So now in the next step we simplify this equation, and here you see that this 2 and square root are cancelled by each other, and we apply the nice square identity in the left hand side, and it will be looks like in this form: a square. So we have our a is 2n, so 2n square equals to 4n square plus 1 minus 2 times of 2n into 1, and this whole equals to 5. And now in the next step we simplify this equation, and we obtain here 4 times of n square plus 1 minus, here you have 2 times of 2n equals to 4n, and we move this 5 in the left hand side, and this whole equation equals to 0. And now this equation implies that 4n square and minus 4n minus 4 equals to 0. We subtract 1 minus 5 equals to minus 4, and we have this is the 4n equals here. So now you see that 4 with the common expression, so we common term, so we divide each expression by 4 on both of the sides, and we get its output in this form. So these all 4s are cancelled by each other, and we get n square minus n minus 1 equals to 0. So here we separate the term n square, and we move minus n minus 1 to the right hand side, and we get n square equals to n plus 1, and we denote this equation by 1, or we call it as 1. And now in the next step we move towards our finding. So our finding is that we need to find the value of n to the power of 12. So that we write here, now in order to find the value of n to the power of 12, we first write this n to the power of 12 as n square and its whole power 6. And now we use here the above equation 1. So here you write that equation number 1 implies that n to the power of 12 equals to, we substitute the value of n square, it is n plus 1, and it will becomes n plus 1 and its whole power 6. And now in the next step we break this exponent, and we write it as n plus 1 and its whole square and its whole cubed. So you know that these 2 and cube are multiplied by each other, and we get 6. And now here we use this nice square identity, and we get its output in this form: n square plus 2n plus 1 and its whole cubed. And now in the next step we again use equation number 1 here. So in equation number 1 we have the value of n square is n plus 1. We substitute this value in this equation, and we get n plus 1 plus 2 times of n plus 1 and its whole cubed. So here we add or subtract the like terms, and we have n plus 2n becomes 3n, and 1 plus 2 equals 1 plus 1 equals 2 and its whole cubed. And now in the next step, we break this equation and we write it as 3n plus 2 times of 3n plus 2 and its whole square. So now we simplify first this square and we expand the square of 3n plus 2 and we get the output of this term. After applying the square identity, we get 9 times of n square plus 4 plus 12 times of n. And now in the next step, we again use here equation number 1. So in equation number 1, we have the value of n square. So we first write this factor as it is and we substitute the value of n square here, and we know that in above equation 1 we have n square equals to n plus 1, and this is plus 4 and plus 12n. And now we again simplify the terms and we have 3n plus 2 multiplied by, we multiply this 9 on both of the terms and we get 9n plus 9 plus 4 plus 12n. And in the next step we have 3n plus 2 multiplied by, we have 9n plus 12n equals to 21n and 9 plus 4 equals to 13. And now in the next step, we have these two factors, so we multiply these two factors each other and we get, first we multiply this 3n, we multiply this 3n to this factor, and after that we multiply this 3n to this factor and we obtain 3 multiplied by 21 equals to 63 times of n square, and 3 times of 13 equals to 39n, and 2 times of 21 equals to 42 times of n, and 2 times of 13 equals to 26. And now here we again add or subtract the like terms and we get 63 times of n square plus 39 plus 42 equals to 81n and plus 26. So here we again use equation number 1, and in equation number 1 we have n square equals to n plus 1. So we substitute the value of this n square and we have n plus 1 plus, here you have 81 times of n plus 26. So we multiply the 63 on both of the terms and we obtain 63 times of n plus 63 plus 81n plus 26. So now we again add the like terms, and first we add 63 plus 81 and we obtain 144 times of n plus 89. So in the given question statement we have the value of n. So we have the value of n is the golden ratio, which is denoted by 1 plus square root of 5 divided by 2 and plus 89. And now we again simplify this expression and we get here, these are cancelled by this one and we get 72, and we have 72. We multiply the 72 on these two terms and we obtain 72 plus 72 times of square root of 5 plus 89. And now we add 72 plus 89 and it is equals to 161 plus 72 times of square root of 5. So this is the required value of n to the power of 12. And this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.